lesson on circles. And it might be a different idea than you've ever done before to do with circles. This is more of a pre-calculus idea of circles than what you have done before, maybe in middle school, maybe in ninth grade or 10th grade. Let's look at this. This would be a new, completely understanding mathematically. So this unit that we're starting into is going to be called conic sections. This means sections of a cone. So this is actually called a double cone. So you have a cone on top and a cone on the bottom. For one of these conic sections, you need the top and the bottom cone. Here you could either have the top or the bottom. If you take a section of a cone and look at its cross section, because that's really what it's talking about, if you take a slice and it's perpendicular to the bases and you look at it for a cone, what it creates is what's a circle. Now, we're going to learn each one of these in the next few days. Get organized here. If you do the same thing, but this time instead of perpendicular, instead of parallel to the base, if it's at a slant, then that cross section at a slant is called an ellipse. Sometimes there are those that want to call that an oval, but in mathematics, an oval is called an ellipse, and a perfect ellipse is actually a circle. So all circles are ellipses. So mathematically, that's what we call it. If you slice it vertically, and it's only one of them, then what you create for a conic section is a parabola. Now we know that is a quadratic equation, but we're going to understand a parabola as a conic section. That means a cross section of a cone in this, rather than a quadratic equation. And then here's where the double cone comes in. So vertically, if we slice it from top to bottom, you actually see two parabolas going in opposite directions. This mathematically is called a hyperbola. In English class, you might have heard of a hyperbole. That's when you exaggerate something for a point. But this has nothing to do with exaggeration. This is a mathematical word to describe a cross-section of a cone, and you would see two parabolas for that, and this is called a hyperbola. Now, for each one of these, there's going to be lessons for them. So today is the simplest one, just a circle. But we're going to understand it as a cross-section of a cone, and what equation then comes from this. Most of these are not functions. Most of these are relations. So in other words, they're going to fail the vertical line test, but they are still an equation and they're still a relation, but they are not functions. That might be important to know as we go through this. So, do you remember what the equation of a circle looks like, or not? Let's look at it. And the equation of a circle would be x subtract h squared plus y subtract k squared is equal to r squared, where the center of the circle is hk, and the radius is r. Now, this is going to be a new word for the conic sections, for these cross sections, and it's the word locus. Now, the word locus is singular. You're also going to see the word loci. That becomes a soft C when there's more than one locus. So all conics have a locus. Different than a locust with a T at the end. Or a set of points that satisfy a certain condition. Now, each conic section, each cross section of a cone, have their own conditions. For a circle, the condition is like the radius. So think of the locus as the locus is all points equidistant from the center of the circle. So the locus for a circle is all points equidistant from the center of the circle. So every point on the circle is considered, in this case, the locus. That is just a mathematical word that describes a conic section, new vocabulary. There'll be new vocabulary for these lessons. So there's your introduction to it. So our first skill is, can you graph a circle? So I want you to look at one. The two things I need are the center of the circle. So when it's in standard form, you just have to do the opposite sign that you see. So it's going to be +1 and +2. And then for the radius, it's going to be the square root of the number you see. So the square root is going to give you the radius. So we're going to go to our circle, or graph, and find 1, 2. And then from the center, going north, south, east, west, we're just going to count 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, I think it's right here, if I count right, I think it's 10. So I'm just going to go quick. 8, that would make this 7, I think, right here. And then 8 down. Okay, and now probably the most challenging part. Can you draw a circle if you have 4 points around it? So try your best. Go like 1/4 at a time and curve. 1/4 at a time, curve into the other point. Do your best you can. There's my best for right now, and you just did it. Let's try it again. Number 2, can you graph this circle? I don't see a number inside the parentheses. In fact, I don't even see parentheses. That means the x-coordinate of the center is 0. Here, the y-coordinate is -5. And then it's the square root of the number it's equal to. So the square root of 9 is 3. So start with the center, 0, -5. 1, 2, 3, 4, 5. And then from that, we're going to count 3 in all directions. So 1, 2, 3. 1, 2, 3. 1, 2, 3. And then 1, 2, 3. And then the hardest part, likely, can you draw that circle? So can you connect the points that you have and do your best to draw your circle? All right, turn the page. So next step is, can you rewrite these equations? So these equations here are not going to be in standard form. So we need to be able to write them in standard form so that we could graph them if we need to, and be able to identify the center and the radius. So this is not in standard form, the way it looks. So to write it in standard form, you would divide everything by 3 and then write it down. So it'd be x² plus y². Now 3 goes into 192 evenly, 64 times. So therefore the center in this case is at 0, 0. And the radius is the square root of 64, which is 8. So number 4, is this in standard form? So we have x subtract 4 squared, but this here is definitely not in standard form. So we're going to add y² to the right side, and then I'm going to add 52 to the right side. Notice +2 I just left on the right side. And then 2 plus 52, that is 54. Now, what is the center and radius of this circle? So the center, the x-coordinate is 4 and the y-coordinate is 0. You can leave this unsimplified. It's just the square root. It's not a perfect square, so we'll leave it as a square root of 54. You could simplify it, but that's not the skill for today. Number 5. Now, this becomes more challenging, 5 and more. We need to know how to complete the square. Now, that's a skill you practiced last year for quadratics, is to create perfect squares. So we're going to go step by step through that. And the more you practice, the quicker it'll be to be able to do it. So this first step is to combine or put together the x's. So we have x² and 6x. They need to be together. And I'm going to leave a space. Actually, I won't even leave a space. I'll do it in the next step. So the next I'm going to do the y's. So y² and 2y. And then any constant needs to be on the other side of the equation. So I'm going to subtract 6 so it's on the right side. Now, I want you just to look at the x's and complete the square for x. Now, I'll do it on the side here. You take the linear one, so the not the one that's squared, but the linear coefficient, and you're going to do two things. You're going to divide and you're going to square. So 6 divided by 2 and then square it. So that's 9. So what we're going to do is go x squared plus 6x and then 9. And then we're going to do the same thing for y. Now, whenever you do something to one side, you're going to have to do the same to the other side so it stays the same equation. So I added 9 to the left, I need to add 9 to the right. I'm going to do the same for y. And again, I want to challenge you to do this mentally. Can you take 2 and can you divide it by 2 and square it? So eventually we're going to be able to do that in one step in our head. 2 and then divide by 2 and square it. So that's equal to 1. So we're going to add 1 to both sides. Now, for the x's, that's now a perfect square, so I can factor it. What two numbers multiply to 9 and add to 6? That's positive 3. For the y's, same thing. What two numbers multiply to 1 and add to 2? That's 1 and 1, so we write it squared, perfect squares. And then add up the constants on the right side. So that's negative 6 plus 10, that's 4. It's now in the correct form. So the center of this circle is at negative 3, negative 1, and the radius is the square root of 4, which is 2. All right, let's challenge yourself for number 6. So we have x squared subtract 14x. We have y squared plus 4y, and the constant's already on the right side. We are going to divide by 2 and square in our head. So let's do that. Negative 14 divided by 2 is negative 7. And you square it, it's 49. And what I do to one side, I got to make sure the other side. So when I'm done writing, I got to go plus 49 on the right side. I'm going to do the same thing here for y squared and 4y. So for 4y, can you divide by 2? 4 divided by 2 is 2, and square it, that's 4. Now we know the two numbers we're going to add to the right side. That's 49 and 4. Now we're going to factor. So for the first one, two numbers that multiply to 49 and add to negative 14. Be aware it's going to be a negative here. Same thing for y. Be aware. Two numbers that multiply to 4 and add to 4, that's 2 and 2. So now this is in standard form. Combine the constants together. So 28, 49, and 4. Altogether, that's 81. That means the center of the circle is at positive 7 and negative 2. And the square root of 81, which is 9, is the radius. Number 7. Let's try this again. So we have x squared plus 20x. Now I see the y squared, so I'm just going to add y squared to the left side. And I see positive 103. So I'm going to subtract 103 to the right. Now, only if it has a linear term do we need to complete the square. For y squared, there is no y in this equation. So I don't need to complete the square. Y squared is complete, and I can leave it alone. So the only one I need to complete the square for is x, because there's a linear term connected to x squared. So how do I complete the square? What number do I add? So divide by 2 and square it. So 20 divided by 2 is 10, and if you square it, that's 100. The y, I don't need to mess with. And then on the right side, I got to make sure I add 100, like I added 100 to the left. Now, complete the square for x. That's 10 and 10. The y squared leave alone. And then combine this together. So that's 104, take away 103, that's 1. So where's the center of the circle? It's at negative 10 and 0. And then the radius is the square root of 1, which is 1. Number 8. Step 1, bring the x's together. So x squared and negative 8x. We have a y squared. We have a y. On the other side, we have 12y. So we're going to subtract 12y, so it's on the left. And then we have a negative 7, and that's the only constant there. So there's step 1, is to rearrange so the x's are together, the y's are together, and the constant is on the other side. I need to complete the square. So divide by 2 and square, that's 16. For negative 12, divide by 2 and square, that's 36. And then what are the two numbers I got to make sure I add to the other side? That's 16, and that's 36. Now factor. So we have negative 4 and negative 4. we have -6 and -6, and then combine this together, 36 and 16 and -7. So that's 45. So the center of the circle is at +4, +6. Make sure it's the opposite sign. And then the radius is a square root. Now 45 is not a perfect square, so you can just leave it as a square root of 45. Rearrange this. That's x squared. There's no other x's, so I don't even need to complete the square for x. We have the y. The y squared must be positive for it to be that circle. So we're going to add y squared. We have an 8y that's there already. We have a 105 on the right side, and we're going to subtract 13 so that we've rearranged the equation. X squared we leave alone. We don't need to complete the square. There's no x's also there, but for the y, we have an 8y. That means we need to complete the square. So we're going to divide by 2 and then square it. So that's 4 squared, that's 16. So 16 needs to be added to the other side. So we have x squared, factor the y, that's y plus 4. 4 times 4 is 16 and adds up to 8. And on the right side, 105, take away 13, plus 16, that's 3, that's 108. 108 is not a perfect square, so the center is at 0, -4, and I'm just going to write the radius as the square root of 108. If I had to estimate what that is, it's 10 point something, because the square root of 100 is 10, and 11 times 11 is 121, so it's like 10.3 or something if I had to estimate, a little bit more than 10. But I'm just needing to write in standard form and then write down the center and radius. One more time like this. Y squared and 10y. Notice we have a negative x squared. We need to add it. It needs to be positive. The x squared and y squared need to be positive for a circle. So we need to add x squared and subtract 2x. We already have y squared and 10y. And then we're going to subtract 2 to the right side. I'm going to complete the square. So to complete the square for x, it's 1. To complete the square for y, it's 25. And then I'm going to add that to the right side. So that's 1 and 25. I'm going to add to the right side. To factor, it's -1 and -1. To factor the y, it's 5 and 5. And then the right side, to combine like terms, I get 24. So the center of the circle is at 1 and -5. And the radius is the square root of 24. And I don't need to simplify that right now. All right, next page. Sometimes, so the standard form of a circle is x plus h squared and y, x minus h squared and y minus k squared is equal to r squared. That was on the other page. Where hk is the center and r is the radius. If I give you information about writing these equations, could you write the equation based on the information given? So in the other one, I was looking for the center radius. Here you're given the center radius. Maybe you're even given the diameter. You just have to divide that by 2. Can you take that information and work backwards? So the center, the x coordinate, change the sign, x plus 2 squared, plus, change it, y plus 7 squared, and then we are going to square 16. So 16 times 16, working backwards. And that's it. That equation matches with that information. Let's try it again. 0, so I just need an x squared. 1, so it's going to be y subtract 1 squared. And then I'm going to square this to make it equal to it. So 3 squared is 9, and root 6 squared is 6. So it's 9 times 6, so it's equal to 54. Again, the center, the x coordinate, change the sign. The y coordinate, change the sign. And then square 24. Watch, it's the diameter, right? So if the diameter is 24, divide by 2, we're squaring 12 because you got to square the radius. So it's 144. Be a good reader. Here, x coordinate, x plus 2 squared. Y subtract 6 squared. and then square root 30. Well, it's the diameter again. So the radius is root 30 divided by 2. So if I square this, root 30 squared is 30, and then 2 squared is 4. So that's 30 divided by 4. That's a good answer. Or you can just write it as a decimal. 5, some different information. So I know the center. So I'm going to write that down. X plus 8 squared, and then 0 just means it's y squared. But I'm given the circumference, but I want to know the radius. So I need to know the circumference of a circle is 2 pi r. So if you're given the circumference, you can then find the radius by dividing. So in this case, to find it, I would divide by 2 pi. And then what would the radius equal? 10 divided by 2, which is 5. So the radius is 5. Square it, and you get the answer 25. Let's try that again. So first of all, on the side, I'm going to deal with this. So I know that the circumference is 2 pi r. That's a definition, formula. And that the circumference is 4 pi root 6. So I want to get r by itself. So I'm going to divide by 2 pi to get the radius by itself. Notice the pi's divide out, and you're left with 2 root 6. So now I can write my equation. So that would be x subtract 3 squared, y subtract 4 squared. And then I'm going to square the radius. So if I square the radius, it's 4 times 6, which is 24. All right, number 7. The center plus 1, and then the y coordinate would be minus 1. But the area is this. Now, I'll do this on the side here. The formula for area of a circle is pi r squared. Now, the good news about that is I really just want r squared. I don't want r. I want r squared for my formula. So to get r squared by itself, you just divide by pi. So if I divide by pi, what I'm looking for is right there, 324. So if I understand that, for the next one, I can just write it down right away. X plus 5 squared, y subtract 6 squared. The area, just divide by pi to get r squared, so you're just left with 10 root 2. How about off a graph? Can you write the equation? So off the graph, what are the two things I'm looking for? So first of all, I'm looking for the center. So could you find where the center is? You might have to count the squares to find where the middle is. So the middle is right there. That's at -4 and -1. And then count how many up and how many down for the radius. So from the center, if you count to the right, or count up or count left, I think the radius is 5. If you count and then put that together, that's x plus 4 squared plus y plus y 1 squared, and then 5 squared is 25. Here's a tiny little circle. Could you find the center of that? Count how many across. So if there's 4 boxes across, then 2 is the center. And then that also gives me the radius. So what is that point? That's 1 to the right and 6 down. That's 1 -6. And I just said the radius is 2. 2 to the right, 2 up, 2 down. So can you put that information together? So that's x minus 1 squared. That is y plus 6 squared. And then 2 squared is 4. Done. All right, last part of the lesson. Right here. Now, this part of the lesson is going to use what you learned in middle school, maybe in 9th grade. That we have, if you know 2 points, do you know the distance formula for 2 points? I'm going to give it to you right now. To find the distance between 2 points, this is like using the Pythagorean theorem, x2 minus x1 plus y2 minus y1. So these are like the legs, x2 and x1 and y2 minus y1. Those are the legs. So think of this as a squared plus b squared equals c squared, but to get c by itself, you square rooted it. And then to find the midpoint, it's just the average of the x's. So if you have 2 points, you would add the x's together and divide by 2, or add the y's together and divide by 2. Think of this as the average of the x's or the y's, whatever we need. So let's look at number 11. In this case, we have a point on a circle, and we have the center. And so what we need to do is find the radius for our equation. So in other words, we need to find the distance between there. So step one, to find the radius, oh, I'll call that's an r, it's going to do d, but it's really r. It's the square root of, and you're going to subtract the x's and subtract the y's. Order actually doesn't matter as long as you're consistent. So I'm going to go 2 subtract negative 5. Well, 2, be careful, I'll write it down, then I won't write it down as much. When you subtract a negative, you're adding. And then 3 subtract negative 6. So be careful when you're subtracting negatives. So in this case, we have 7 squared, and in this case, we have 9 squared. So 7 squared plus 9 squared, that is the 7 squared plus 9 squared is 49 and 81. So 49 and 81, that's 130. But I want to square that, so I'm not going to simplify it. So square it, it's just going to be 130. So what's the equation of the circle then? We'll take the center. So the center, we're going to have x plus 5 squared. We're going to have y plus 6 squared. And then the squaring the square root, they undo each other, and that leaves you just with 130. So that's what r squared equals. Again, a center and a point on a circle. So we'll do this a little more efficiently. So do you know the distance formula? So subtract the x's. So that's 6 squared. Subtract the y's. Be careful here when you subtract a negative. So it's negative 15 plus 10. So that's negative 5. So if I put that together, it's the square root of 36 and 25. So that's the square root of 61. So now I can write the equation down. So that is x minus 4 squared using the center, y plus 10 squared, and then square a square root. They undo each other, so it's just 61. So it actually makes it a lot simpler, the last step. Again, if you know a point on a circle and a center, could you find the radius? So it's the square root of. Subtract the x's. Negative 9 subtract 2. That's negative 11 squared. Subtract the y's. That's negative 7 squared. So that's 121 and 49. So altogether, this is the number I need, is 170. So we have the center. So it's x subtract 2 squared, y subtract 2 squared, and then square and square root, just left with 170. Done. One more time. Can you find the radius using the distance formula? So it's the square root of, what's 2 subtract 8, negative 6, square it, I'm just going to go for it, 36. I'm going to do it again, negative 2 subtract. Now when you subtract a negative, you're adding. So negative 2 plus 3, that's 1, and square it, you get 1. So the radius is the square root of 37. 37, here we go. So it's x, the center. X subtract 2, it's y plus 2, and then square a square root, you're just left with 37, and you're able to find that equation of a circle if you're given certain information. All right, here's our last part. What happens if you're given the endpoints of a diameter? So if I know they're the ends of the diameter, I need to first of all find the center. And the center is going to be the midpoint. So to find the center, I'm going to find the average of the x's and the average of the y's. So what's 1 and negative 5? Can you add it up? I'll write it out first, and then it'll be shorter. Divide by 2, and then again for the y's, negative 16 plus 4, and divide by 2. So that means this is negative 4 divided by 2, that's negative 2. This is negative 12 divided by 2, so that's negative 6. So using the midpoint formula, that means you add them and divide by 2, you can find the center. Now we need to do the next step, which is to find the radius. So now take one of the points. I'm going to use the smaller point, which is negative 5, 4, and I'm going to subtract and square. So I'm going to go negative 2 subtract negative 5. That's adding, so negative 2 plus 5 is 3. Square it and you get 9. I'm going to do it again. Negative 6 subtract 4 is negative 10. Square it and it's 100. So this is the square root of 109. Now we're going to put it together. So we have x plus 2. squared. We have y plus 6 squared, and then square the square root, and you get 109. Let's try it again. To find the center, it's the average, and I'm going to do some of this in my head. So can you add the x's? What's 9 and negative 17? That's negative 8. Divide by 2, and you get negative 4. Add them again. 1 plus 5, that's 6. Divide by 2, that's 3. So our center is at negative 4, 3. To find the radius, it's using the distance formula or the Pythagorean theorem. So I need to find the difference of the x's and the y's. So negative 17 subtract 9. That's negative 20. Negative the x's. Oh. So we have our center. Sorry. I have our center, and I can use one of the points. So I'm going to use the first point instead of 17. So subtract the x's. Negative 4, subtract 9. That's 13. And can you square 13, or negative 13? You get 169. 3 take away 1 is 2. Square it, it's 4. So if I put that together, that's 173. So that's all I need. This is x plus 4 squared. That's y subtract 3 squared, and then square a square root, and you get 173. Let's try it again. Center. So 6 and negative 4, that's 2. Divided by 2 is 1. We're just finding the midpoint. Add them. Negative 3 and 9, that's 6. Divide by 2. And then to find the radius, it's the square root of. So I'm going to take the smaller values here and subtract. Either point will give you the same answer. 1 take away 6 is negative 5 and square it. That's 25. 3 subtract negative 3. That's 6. And squared is 36. And then add them together, and it's the square root of 61. So now put it together, and you have x subtract 1 squared. You have y subtract 3 squared. And when you square a square root, you get 61. All right, last one for the lesson. Can you do this? Try it. You want to try press pause and do it, and then press play? Let's see. Midpoint. So negative 3 and 15, that's 12. Divide by 2. Negative 1 and 9, that's 8. Divide by 2. The radius, the square root. So use the center. So 6 subtract negative 3, that's 9. And then square it. 4 subtract negative 1 is 5. And square it. So if I combine these together, that's 106. And now I have my equation. X subtract 6 squared. Y subtract 4 squared. When you square a square root, that's 106. Done. All right, you did your work. I am so proud of you. Mr. G Math over and out. Until next time.